5. Now give me a second here. Let's see the latency. There you go. How you guys doing? Looks like we're dropping some frames here and there. Whoa, ho, ho. 13% of frames dropped. Maybe it will stabilize in a second. Just ahoy! Error 413. All right, let's see if it's stabilizing. Okay, we're going down to below 10% of frames lost. I haven't had this issue before. That sucks, but you know, that's life. That's the joy of streaming, isn't it? What do we have here? Oh my god, what is that? Jimmius 2? Hi, how you doing, man? How's it going? All right, so what we got today is the CPU. So a few days ago we removed this little tiny CPU off the motherboard, the Dell motherboard, because it is shorted, right? And we're gonna replace it eventually. But when I removed it, I didn't have a stencil. So we just removed the CPU, we wicked the board. We did a little bit of damage to the board, but nothing major. It should work, but we'll see. So now I do have a stencil, and I was actually wondering how does it work that those little cups inside over here, right? How do you put the stencil on top of it if you have these cups over here? And now I have my answer. So there is a little window over here, but the OBS says reconnection successful. What does that mean? I guess we had, I don't know, maybe my internet was slow or something. Too many devices, I guess, could be. Or just Comcast is doing its thing. What Comcast does. Anyways, I have a nice little jig over here. This is magnetic, right? See, two big neodymium magnets, right? And you put a little holder over here. You put the memory chip over here. This is for SSDs, right? And on top of that, well, first you put the stencil. So you put the chip over here. You put the stencil on top of it, like this, right? Like this. And then you put it on top over here, right? And it's magnetic, so it doesn't fall off. It works really well. And I don't know why, but I never had much, or before, it took me a while to get any kind of success reballing. Now, what would happen? Primarily, the stencil would get hot, but not the chip, which means the solder would just flow all over, and it would look awful. And for some reason, this is the procedure that took me the longest to get any kind of success. Not even a lot. At this point, I have, like literally a handful of chips that I reballed. Surprisingly, it was easier for me to figure out how to resolder the sockets or the CPUs or what have you, basically BGA work, than it took to figure out reballing. And the main reason for that is when you replace the socket on the board, basically you get the reballed socket, right? I have one over here, right? Right, the balls are already on there, right? So you don't have to do anything. All you have to do is just align it, right? Obviously you have to clean the board and all that and remove the old socket, obviously. But you just have to align it, right? Heat it up, wait for it to drop, and you're done, right? Well, that still took me quite a few months to get proficient in CPU socket replacements. But with reballing, it took me a long time. And I know what you're gonna say. The trick is the temperature, slowly heating it up. And yes, you are absolutely correct. So what would happen to my stencils, right? Like this one, you see, it's straight, right? It's perfectly straight. But if you just do it like this, you put everything, and either you put the balls on or you put the paste on, what have you. You take the heat gun and you just start heating it up. What happens? The center part, it just kind of pops, right? The stencil becomes bulged up, right? And obviously it's not gonna work. Now, why does that happen? Excellent question. That happens because the entire stencil needs to be heated up slowly and relatively evenly for that not to happen. And once that happens, you will notice that the stencil is going to remain bulged, right? This one's straight, but it will remain bulged. So what I did, I put it on the preheater, right? I heated it up to, I don't remember, like 250, 300 degrees Celsius, something like that. I even heated it up with the header to kind of help it, because it's a little bit bigger than my preheater, right? And once you heat it up evenly, the entire thing, it'll return to its nice flat position, right? And then you cool it down slowly, and you have yourself a perfectly working stencil. Right? It's not warping or anything, right? It's perfectly usable now. So that was the whole trick that took me, for some reason, it took me a long time to figure it out, that it's only a matter of heating it slowly and heating it relatively evenly. So that was the whole difficulty of doing this, is just patience, nothing more. It's just patience. As soon as I got my first success, I first successfully reballed the SSD, because this is for SSD, right? First time I reballed it, it worked, and what I did, well, I gained confidence, right? I was at the very height of the Dunning-Kruger effect, and what I did is I figured, well, I've done it before, I'm gonna speed up the process, and I just put too much heat, too close, too fast, and again, it popped. Basically, it's kind of like the sound that it makes. It's kind of like a popping sound when it deforms, and that center just, because, if you heat up the center, metal expands when it heats up, and it shrinks when it cools down, right? That's a property of a lot of elements, but especially metals. So if you heat up just the center, not the rest of the stencil. So the rest of the stencil, the edges are cold, but the center is hot, then yes, that center doesn't have any room to actually expand, and it's gonna pop, and you're gonna have a big bulge, which obviously you're not gonna have good connection with the chip, and it's not gonna work. So that was the whole. It's really simple, but it takes well, it took me a while to figure out. Although you guys did tell me that, you guys did give me good you know, push in the right direction. You gave me good advice and everything, but until you figure that out yourself, just test it yourself, you know, even with the best advice, it's gonna be difficult. So in this case, you just, I don't know, I just had to see it myself, just you know, just figure it out myself. That's usually how I do things. I just have to figure them out myself. That's how I learn, at least. But yeah, all your suggestions were absolutely awesome. Let's see the chat. Oh my god, those nicknames. Oh my god, guys, I sometimes I feel like you're trolling me with those nicknames. Stuzistu. I was gonna say different flags. Oh, so with flags, it's also because I started with small memory chips, not even SSDs. Those tiniest memory chips that go. I had one over here that go on RAM sticks, right? These are really tiny, and I managed to even do one doing balls by hand, just putting a little bit of flags on the chip and put ball by ball on each pad, and I managed to reball it that way. But for the life of me, I couldn't reball it with the stencil for the same reason. And I was blaming my jig, like, yeah, I need a magnetic jig so it holds the stencil. But even these two big neodymium magnets, they're not gonna hold the stencil that is heated up inside, but not on the edges, and it's still gonna pop. It's still gonna deform. And then to put it back in the position, you have to heat it up the entire thing again, just so it returns to its flatness. Yeah. Okay, so now the issue is, do I have proper jig to put it on? I do not. Again, let me just pick up on the chat. Bapplejack? I don't know. I'm trying to read this. Right now I'm hitting MSI X99 Godlike gaming board, prepping for second attempt on chipset removal. Wish me luck. I wish you luck too. Well, good luck, man. A chipset removal, that shouldn't be too hard. If you're using my setup and my software, preheat it for about 20-25 minutes just to be sure, but probably 15 will do. Start with lower temperatures, 100, 120, 140, 160, and go all the way to 210 at the bottom, 205 at the top. My standard CPU socket profile, my standard CPU socket profile should do. It's really, with chips, it's a lot easier than with sockets. But yeah, let me know how it went. We'll be waiting for the update. Stujistu, I learned about metal memory from auto body shops, fixing dents, so it makes sense. Yes, actually, you see, that's an excellent point, because yeah, that's how you fix dents on a lot of metal parts. You fix them by heating them up. So if you have a dent like right here, right, you heat up just this one little spot that is dented, and it'll it'll pop. It'll just straighten itself. So yeah, I've seen that on YouTube. People doing that. It's exactly the same idea. Can you use stencil to put the balls on CPU and then remove the stencil and reflow the balls with hot air with minimal airflow? Yes, some people do that. Some people do that. I'm going to use a paste because that's normally what I use, and the reason for that is I don't know, with those balls, I don't know, it just doesn't really work for me. It's probably because, especially right now, we don't have anything to properly hold it. Now the best option is using this. This is really useful device for this. So you put the chip, you put the stencil, you do everything you have to do, and then heat it up slowly, right? Put the temperature to maybe 205, 210, maybe 220, probably not even 220, depending what kind of solder you're using, but probably 185 is going to be good enough, because that way it heats up from the bottom, and that's what you want, right? So the chip is going to be hot first, so that solder is first going to soak into the chip before even the stencil gets hot. But if you heat from the top, right, then the stencil is going to be hot first, then the chip is going to get hot, which is something you don't want, because then the solder is going to flow to the chip, because to the stencil, because solder is always going to go where it's hot. It's not going to go where it's cold. But all of that said, you can use stencil to put the ball. Oh yeah. I already read that. I wrote removal, but I thought soldering in. My bad. Oh, you're putting the, okay, so you're resoldering it. Yeah, well, as long as it's reballed, as long as you can align it properly, it should be easier. It's probably easier than removal, because then after removal you have to wake the board, and you know, I feel like replacing is the easiest part, because you only have to align it and run the profile, and that's it. You don't even have to look at it if you have tested profile for any particular board. If not, you know, just put the microscope from the side and see when the socket drops. That's what I do. Okay, so here's the problem. So we have one stencil or jig that is not for this, because the stencil, right, is too small for this. Plus, this is only for square chips, right? So it's not even gonna hold the CPU. I have this one that I was thinking maybe we can use, right? It's a really crappy one, but I've used it before, and there are two magnets over here. So if you have the big stencil, like, you know, something like that, right? The magnets are gonna hold it. It's pretty cool, but it's too small for this CPU. We have the memory, right? But this part doesn't fit, right? But I'm guessing we can use this and just put the CPU on it, then put the stencil, and the magnets are gonna keep it nice and steady. Now, the only problem with this is, as you can see, there's plenty of aluminum at the bottom. It's aluminum or steel, not sure. Because the only problem with this is that when you heat up the magnets, they kind of lose their strength, right? So they're not going to hold as well. But as long as you heat the entire stencil evenly, you should be fine. And actually with a memory, right, because look at the difference, right? So with memory, it's a little harder because you have much higher surface, right? Much more of a surface. to heat up, right? This one is a lot smaller, so it shouldn't be that much of an issue, it bending and stuff and deforming. So it should be a little easier, but we'll see, because one other thing that I always struggle with is also applying the paste. You don't want to push too much paste inside, right? You want the same amount of paste in every pad. So that is relatively tricky as well. So I guess we'll see how it goes. I think I'm going to try on this one. I think I'm just going to give it one try because I'm a little tired. It's been a long day. We had a lot of ECMs for repair today, and a lot of stuff in general. So we're not going to drag this along. Let's try one reballing. If it doesn't work, it doesn't work. It's good enough. Good enough for me. But first, we need to clean the CPU. Now this CPU that we're gonna do, this is the shorted one, right? So we don't care about the CPU. This is trash at this point. But I'm not gonna work with the actual replacement because first I want to get a feel for it, right? This is the first time I'm using this stencil, so we're gonna take it easy and try to just basically not screw it up, right? And that'll give me some idea of how difficult it's going to be. So I'm gonna remove the nozzle. Right now I got 380 at 75, that's fine. I just want to preheat the CPU first a little bit. Alright, so it's easier to wick. Because I don't want to switch the handle or switch the tip on my soldering iron. So, you know, with proper temperature it should be easy. It needs to be clean, nice and clean, because otherwise obviously you're not going to be able to reball it, right? So let's start here. Let's put generous amount. That should do it. Smells nice. And now let's just wick the whole thing. Oh, it's got plenty of thermal mass. I may need to... see? It's got... the CPU has too much thermal mass. So my soldering iron alone is not capable of heating it up enough to wick it. Which makes sense, because these components heat up, right? They need to be designed to dissipate that heat quickly. Which is, well, I'm glad I'm finding that out now, because I know it's going to be a problem with reballing. So if this is the amount of heat it needs just to even wick it, then it's not going to be easy to reball. Right? The memory chips that I've done so far, they're tiny. They heat up very quickly, and you know, wicking is very easy. But if I have this much problems even wicking it, then I know reballing is going to give me issues. So let's see. And yeah, I'm not using the proper tip for wicking, but that's fine. That's fine as long as we have a header to aid a little bit. It should be fine. What do we have in the chat? No, use 183C. Hang on. You can burn the IC, burn the IC die if you don't cool it in time. Be prepared for cooling plate. I've no. What do you mean, Jimmy? Use 183C lead. Yes, the paste I'm gonna use is definitely, you know, it's gonna melt at 180 whatever. It will. So let me drop the temperature in that case to 300. Well, when I put it on the BGA station, I'm gonna use my standard profile, which is 205 at the top, right? So the CPU is gonna be warmed up to 205. Should I use lower temperatures? I could, because normally when they drop, even the sockets and stuff, when they drop at like 185, 190 typically. I keep it for you know, until 205 because, you know, I want to ensure that everything solders on correctly. But maybe I'm using too high temperatures. That's very possible. It's always great to watch you working. Thanks, Joey. Thank you, Joey. Always nice to have you here. This SIFO reballing the cooling plate. I have no idea what you're referring to. I guess I'm gonna learn something new today. Or are you talking about the plate I showed earlier? It's not soaking very well. There's plenty of solder still on the pods, and I don't want to leave any. But probably what I should have done, and I guess I can still do that. Let's get it like this maybe. Oh, no, that's not gonna work. Yeah, I need to do one side and then the other side. Let's put some leaded solder on it. I think that's what you meant. Lead, use 183 lead. Yeah, because it's not wicking well. So let's give it a little lead over here. And that should help with that. And everywhere here. Come on. And there. I don't have a big enough jig to just hold the whole CPU, right? To have access to everything. So we're gonna have to do it one side first and then the other side. Now, if I remove some caps, we're gonna ignore that because again, this is shorted CPU. I'm just testing the procedure, right? So I know how to do it on the other CPU. Plus, I want to include this service in my service list, right? The CPU swap. All right, not very expensive. You send the board, you send the replacement CPU or the donor board, and I just swap the CPUs on them. That's what I'm thinking, but first I gotta become relatively proficient in this. With the socket replacements, it took me quite a while to become proficient, so I'm not expecting excellent results today, but I'm expecting to learn something new, test my skills, that kind of stuff. Okay, let's see. We'll see in the next wicking round if the leaded solder did its job, because there's still plenty of solder staying behind on those pods. I want to see nice flat pods, because if there's any little bit of solder even left on it, it's gonna be hard. It still can be done, but it's gonna be hard. Plus, you want the same amount of solder on each pod, otherwise the CPU is not gonna drop properly. Come on. It's better after putting some lead on it, but it's still not what I would expect. See, the memory chip would have been completely wicked by now, but the CPU, it's just dissipating too much heat, so that solder wants to stick to the CPU still. It doesn't want to leave. But we're very close. CPU should be pretty warm now, just from the soldering iron. I'm not sure here. Yeah, I still see few pods still holding on to some solder. But we're very close, because at least now I see the actual pods. Before I would just see the blobs of solder. Mix lead solder with no lead solder to low the wicking. Yes, that's what I did. It does help, definitely. The flux looks to be working good. I like it. You might look at it like, look, it's burning. Well, it's supposed to be burning, but you see how well it looks, and you don't need a fume extractor. That's what I care about. Because my son spends a lot of time in my shop, so I don't want to use nasty chemicals. Although I don't let him sit here when I do BGA work, but still, any kind of soldering, you need flux. Alright, so my incentive is to have a flux that is safe for kids. Or at least, not some nasty chemicals that come from those synthetic or chemical flux types. But to each their own, because you might look at it and say, oh, this flux burns too quickly. Well, it may be burning, but you can see that it still works even when it burns. And when it's warm, it's easy to remove. When it dries out, it cools down and dries out, it's a little harder to remove. You have to you know, work a little harder with your, you know, alcohol. But it's still, you're gonna get the job done. You know, King Bow would probably, you know, do it faster, but King Bow actually, it burns faster, too quick. In my view, it burns too quickly. I will eventually try Alex's flags, and we'll see. I'm curious of what it smells like and that kind of stuff, and how it burns, because there's some conflicting information. You know, Tony says that it burns. Alex says that it doesn't burn. So which one is it? And how do you even produce a flax that doesn't burn? If it doesn't burn, it doesn't work. That would be my expectation. Okay, I don't know. It looks like it should be good now, or at least good enough. Let's maybe do one last wicking, just to confirm. But I don't see any, because normally when you move across the pods, you don't want to see any, you know, flags. Just kind of, you want a flat, nice flat pod, right? When there's any solder left over, when you remove the iron, you can see as the solder solidifies on it. All right, and I don't see that anymore, so it looks good to me. Yeah, the flax is pretty much burned, but as you can see, it still works even though it's burned. And I don't want to scrape too much either. Yeah, big leaded bowl to your iron. Yeah, that's pretty much what I did. Now let's clean this and see what we're working with. But I think it's fine. I think at this point it should be perfectly fine. Yeah, I don't feel any resistance under the Q-tip. Usually when there's flax left over, or not flax, the solder left over, you can feel a little bit of resistance, like it's you know, it's catching the fibers from the Q-tip. But this looks okay. It should be fine. Now we'll see how well this flax is gonna do for reballing. That's the main question. There, what is that? To remove even big, flooded with new flax you have. The new flax looks good. Yeah, I kept it a bit too long. I let it burn, so you can see burnt flax. But as you can see, even when it burns, it still does its work, right? It's just harder to remove. But it's just a matter of, you know, swiping like this. All right. In the ultrasonic cleaner, it would take a little longer, right? Because it, so if you burn too much flax, it might require a little longer run in the ultrasonic cleaner. But just alcohol, nothing else, and it should work. It should clean out nicely. Now it's not catching. I don't feel anything catching. But looking at it now, what do you think? It kind of looks like some pods still have a tiny little bit of solder on them. I'm not sure. Yeah, like absolutely minimum on some of them, I think. Yeah, to remove even all the remaining solder from the pods, use hot air and Q-tip to drag out remaining solder. A Q-tip for solder? Interesting. Isn't the Q-tip gonna burn? It's cotton. It's got relatively low burning temperature. I can try it, but it kinda doesn't sound very intuitive. Alright. Okay, let's do this side now. And then we're gonna do the center. What did I lose? Oh, I see. The cup. Alright. Renew your flux. Yes. No, I think your flux is a brilliant idea and works really well for sure. It's a compliment to you, Raf. Thank you so much, Joey. Have you tried it? If you want, I can send you a complimentary batch if you want to give it a try. But yeah, I love it. I love it. I use it. You know, I put my money where my mouth is. You know, because if you saw me selling flux but still using Kingbow or something, then yeah, obviously it's a grift. But the only reason I sell this one is because I use it. It works for me, so I'm just sharing it. Right? It's not exactly a business for me. Oh. Now use a Q-tip and hot air, but with flux, or how do you mean? Like, is the Q-tip gonna catch the solder? Is that what you mean? Do not burn, no flux, do not burn the Q-tip. Okay. Alright. Well, I flooded it with flux now, but I'm gonna test it in the center. I'll clean this up and I'll test it in the center. Now this is catching because the CPU is too cold. Looks like I have failed. A little bubble showed up on the substrate, but this time it is only one, not half of the chip. That's a little success. Yeah, take little successes, you know. Even if it wasn't 100% successful, you know, collect the information where you did succeed, right? And take those little wins, because it's not easy to get successful right away, right? You have to pay your dues. You have to fail a few times, but yeah, definitely see where the little success was, and then start correcting the problems that you identified. And I forgot to put leaded solder on this, so this is not working very well. But let's see, first let's get the majority of this old flux, or this old solder, and maybe, you know, because I've done especially with this flux, usually I do wicking without putting any extra leaded solder, right? I just wick it right there, then and there, and it works, right? So it's usually just a matter of temperature, right? Especially when you subsidize with hot air, it should remove all the solder. But it still should flow. It's just a matter of reducing the melting point. Yeah. So it's just easier with leaded. but as you can see, well, we still have plenty of solder on this, but we're grabbing it. It's going away. Just takes a lot of wick. And you said in the previous one, put more fresh flax on it, and you're absolutely right. Because even though that burnt flax still is doing its job, not as well as the new flax would. Mix with 183. Bristle brush works well too. Oh, Dream Spec, how you doing, man? I've seen this method on some either Indian or Pakistanis doing the revival of the radiators, the car radiators. So what they do, they just blow it with a torch and use the steel brush to just get all that solder off. That way they open it. So I know it's a thing, but is it not gonna do too much damage, scratching damage? Because I know it works for the radiators, but they just have to not leak and that's it. They're not very precise components. Not enough temperature. And I'm actually wicking it at 370, so that's a little low for wicking. But as long as you can use hot air, it shouldn't be the problem. Come on, it won't let go. Come on. We're at 300 degrees on the hot air. This shouldn't catch this hard. But I don't want to pull it because we're only on 75 liters per minute. So come on! Oh my God! Look at this. It held it really well. Damn, I did not expect this. Come on, let go already. What is this? At 300 degrees, it won't let go? Crazy, those CPUs. It won't let go. Can you believe this? It should be flowing like crazy now. With this amount of heat? I'm gonna race to 330. Crazy. Come on. With this much heat, it should be just dancing all over this board. There. That's crazy. So 300 degrees wasn't enough. You see, the CPUs are pretty tricky in that regard because they require decent temperature for all this. And it wasn't even that much solder on the wick. This is very kind of you. I live in Netherlands though. Postage would be expensive. I get enough from your good yourself by watching your videos. All right. Well, the package is not that big, so I don't think the postage would be that bad. I sold some stuff to Poland, right? Like those what do you call it? The adapter board for IR 6500, you know, for Windows 11. I shipped it to Poland. I don't remember how much it was, but it wasn't that expensive because it's a small envelope. You know, the weight of the package is 1 ounce. So it's not that expensive. If you want, send me your address and I'll send you the envelope. You know, USPS International. Not like first class or anything like FedEx or those kind of things, because those are expensive, sure. But regular postage, it shouldn't be more than 10 bucks, I would expect. Okay, that's still a lot of solder here. Yeah, I can see it. So I think I do need to put some leaded on it because it's not budging, or it's taking too long. Although I should be able to. Let's do a few more passes, and I think it should get the job done. It is taking long, and sure, it takes a lot of temperature, but it should get the job done. And at least here it doesn't look like I have to worry about scratching, because on the board, if you keep moving the wick as much as I'm moving it over here, it scratches those, you know, little connections here and there, and doesn't look good. And it only, you know, creates more potential of creating bridges, you know, afterwards. Once you replace the chip, right? But here it doesn't look like it's a problem, so I can keep scraping it and just hope for the best. Yeah, I can feel it under the iron. There's still plenty of solder. And it's not soaking that well, but if we subsidize with hot air, yeah, don't you wish you had 3 hands? That would be so beneficial in this business. If I had 3 hands, I would be the best technician, because I could do a lot of stuff that I cannot do now because I only have 2. Come on, not much more. Yeah, the majority is leaving. I mean, it would be so much easier if I put leaded solder on it, but at this point there's so little left that I'm just gonna finish it off with just the wick. No leaded solder. And we'll see, maybe that will be a deciding factor of this not actually working. My main incentive here is to the actual reballing, because, you know, wicking, sure, you have to do it, no way around it, but wicking is no problem. There's so many tricks and it's pretty easy. But with reballing, that's gonna be a challenge. Okay. See all that smoke? It doesn't bother me at all. It's a pleasant smoke. I mean, part of it is, you know, glycerin. Part of it is IPA evaporating. All that bubbling is primarily from IPA. All the smoke is primarily from the glycerin. And the rest is just resin. Pine resin. Pure, organic pine resin. Okay, this looks better. Still changing colors, but the left side looks good. And the right side does not. And then we're gonna try your trick with Hodder and Q-tip, because I'm curious about that. Not the best. Not the best at all, actually. There's still plenty of solder left here and there, and I can feel it under the soldering iron. I mean, I don't know, is that gonna, does it need to be super clean? Like not a speck of solder left, or a little bit of solder left is gonna be good? What do you guys think? Yeah, especially here. Come on. It's almost there. Maybe I'm just moving too fast, because you do need to heat it up. Right? If you move the wick too fast, you're not picking up the solder. Okay, let's clean it up. Should be good. Let's see. The wig said, "I am not going anywhere. It is nice and warm here." That's what it was thinking, I guess, because it was crazy how long it was holding, with 300 degrees and the soldering iron with 370 on it. Crazy. But you can see how much the CPU, how quickly the CPU is dissipating that heat. We need more power, Captain. Yes, sir. That's what we needed. Mix 183 is critical for reballing cleaning, even if you end with 195 balls. Yeah, it's starting to look like it. Yeah, it's extremely hard to wick it without putting leaded solder on it. Right, you are. Okay, fantastic. I would love to try the flags. I will drop you a mail. Thank you, ever so much. Much appreciated, Raf. Thank you, Joey. You got it, man. You got it. And if you like it, maybe I'll open a distribution center in Europe, in Poland. To remove the remaining amount solder from pre-wigged pods, use hodder and Q-tip and Q-tips to drag out the remaining solder. Okay, we'll try that right now. So you mean on those pods that I already wigged, or the new ones that I haven't touched yet? I do think this should do. Yeah, because the Q-tip is not catching, so I know there's not like a lot of solder left on the pods, but I can definitely see that there is some left over. It's not perfectly clean. Let's see. I was struggling to remove solder from R9 930 core chip 2. It has partial IHS 45x45 chip. Leaded solder helped a lot. I was thinking about putting chip on preheater set to 100 degrees next time. Preheating definitely helps, or you can use hodder to subsidize with that. Okay, so you said no. Would a large conical tip make any difference to wicking? Just wondering. Maybe. Yes, the wicked ones. Okay, so I'm kind of cooling it down now, but you said no flux, right? Just hodder and Q-tip. Let us see. Any particular Q-tip or any Q-tip? So I guess I need to heat it up to the melting temperature. And we'll see. My stencil is already preheated because it was next to the next to the jig. Yes, so okay. Alright, I don't know if this is ready. That should be. I got very low, 75 liters per minute at 330 degrees. It should melt the solder. Okay, so far I don't see anything, but I may need to heat it up more than this. Do I just like move it very fast or move it slowly across? Wooded Q-tip better. Yeah, I think this is bamboo. This is not plastic. Yeah. So this should work well for this. It doesn't burn quickly. I'm not sure I'm heating it up high enough. Let's do 350 and try at 350. And let's give it good heating. Well, I don't know. Does it work? Is it working? I'm like trying to like move it quickly, but maybe I should move it slowly. And turn it. I might be overheating it now. Although 350, you think 350 is overheating it? I don't care about this CPU because this one's shorted, so you know, this is just a test run. I don't know, is this working? I don't really see much of a difference. Let me go to 380 or 370. Just let's see what's gonna happen. Because I also don't see the solder doing anything. You know, like leaving or staying on the pads or moving or anything like that. Maybe it's fully clean now, and that's why I can't see anything. 'Cause I don't really see any solder on any of the pads. Can you guys see any solder left over? You see it shining and then you clean it. Okay. I might be using temperature too low for this. Actually, let's do this, because instead of increasing the temperature, let's do 90 liters per minute. That's gonna do it most likely. Oh yeah, it feels different now at high temperature, and it looks like it's doing its job. Yeah, now I see it. Huh. That's pretty cool. Yeah, it's working. Yeah, my airflow was just too low. Yeah, now I actually see the pods changing. Where is all that solder going? Is it use SLA nozzle? I'm using without yeah, small nozzle. I'm using no nozzle, but yeah, I feel it now. Now it's becoming more and more slick, no resistance, so it is working. It is actually working. Now what's gonna happen? It's getting too hot. If I try it over here, so we didn't do anything over here, right? We didn't wick it because the center is still not done. Let's see what's gonna happen. Oh, the solder is not melting. Okay. What do we have here? Ah, that's interesting. I should probably use the new one. Oh. What happened here? Yeah, I probably shouldn't be using that on the unwicked board. Okay, the jig is so hot. Let's remove the CPU of the jig. And let's put it in this one. Just for those middle pins. It's not only hot, it's also sticky. There. I'm not sure what happened here, but well, there was plenty of solder, and I just used a Q-tip. I guess you did advise me not to do that, but I wanted to see what happens. You know. I was using 4mm bevel tip for the GPU when I put leaded solder. I ended the job in reasonable time using wick. I am waiting for T12 10.4mm blade tip. I think it will help a lot. T12, which one is that? Is it bigger than T245? Or is it just bigger than 210, but smaller than 245? You know, ever since I started using T245, I don't go back to T210. Even though it's, you know, it's more precise because it's smaller, but you can do precision work with big tips as well, and it's overall easier. You need good temperature on the soldering iron. What you need is good temperature. No way around it. As long as you have that, everything is easy. The solder listens to you. You know, I started with those crappy, cheap, you know, 10-cent tips. That's what I was using, and I was watching, you know, other people on YouTube soldering, and I was always wondering, why is my solder not listening to me like it does to the other ones, right? And actually that was two reasons. One reason was that my soldering iron sucked, but the other one, I was using a lead-free solder because I didn't know that it was lead-free. I just typed in on Amazon, give me solder, and they gave me solder, all right. But by default in the United States, you get lead-free. In Poland, where I'm from, where I got the majority of my experience, or at least until then, because now I would say probably the majority of my experience is from this shop. But that was by default. We always had leaded solder, and you had to really go out of your way to find lead-free solder. Plus, you know, it took me a while to figure out the flux, because you know, in Poland primarily you use colophony, which is pretty much what I'm using right now. So, and different kind of irons. I was used to the transformer-based soldering irons, right? Not the irons you see nowadays. I don't think they even make them anymore. But that's what I was used to. So, you know, you could think that I already had plenty of experience back then, but that was different tools, different times, different chemicals, all that. So I don't know, every profession is about learning to some extent, especially software and stuff. But yeah, in electronics, especially in the repair business, they come up with new devices all the time, and you have to adjust, right? You can't just retire on fixing iPhone 5, right? I don't think you would make much business repairing iPhone 5s, but back in the day there was so many listings on eBay for iPhone 5 repairs. I've done some myself, but now it's gone. No more iPhone 5s. So now we have to learn to fix iPhone 6, then iPhone whatever, 10s and 11s and 12s and Pros and iPads and all that kind of stuff, right? So it's constant learning, constant adjusting to the circumstances. So yeah. Okay, this should be good, I think. Yeah, we don't need to get it super clean, at least not for now. I don't think it's gonna affect my test today very much, because primarily what I want to achieve is just not have the stencil deform, right? And I want to get all the balls melted, and I want to use the paste. At least that is the plan for today. And if it doesn't work, then tomorrow we'll try with balls, because I think it says, the stencil says 0.45. Yeah, I should have 0.45 balls, so it should be good. So we'll try. If this doesn't work, we'll try balls tomorrow. Yeah, so I'm doing first pass on the lead free, right, and then I'm gonna put some leaded solder in it. There. And now some leaded solder, and I just got burned because the hot wick was underneath my hand in the most painful area. Come on. There. Is it gonna work? Well, lead farmer. There's only one way to find out. But this CPU is dead, right? So yeah, this CPU is not gonna work. But we just want to get a good reballing on it, and that's a prep work for the actual working CPU. So first I want to try it on the dead CPU, get my procedure right, and then I'm going to do it on the working CPU. But first we have to remove it from the donor board. because we just removed the faulty one, the shorted one. And my idea is to provide such service, because I know Nathan's gonna need this service, or at least he mentioned that he's gonna want to get some CPU swaps as well. And sure, he can do it himself probably, but we'll see. I just kind of recently specialize in BGA work, right? So it's always better to leave it to the specialist than doing it yourself. Well, unless the specialist is too expensive or something like that, or the service sucks. I don't know. Okay, I think this should do maybe one more pass. T12. Which soldering station do you use, Rav? This is AFN A9 Pro. It's pretty standard. It comes, the same station comes under many other names, so it doesn't really matter. T12 is enormous in size compared to C245. Tips are cheap and a lot of shapes available. Okay, I'll look into that. Are the JBC compatible standalone and tips from AliExpress any good? That's what I use, because these are JBC compatible tips, right? Well, actually, let me show it to you here, right? So this is chisel. So this is basically, this is 245, right? But these are JBC compatible. So yeah, typically when you get the station, you know, this one says compatible with C210, C215, and C245, right? So any T210, 245 will work with this station. Are they any good though? They are questionable in the sense that they don't actually fit the device as well as the original ones. They are a little bit shorter. They work, sure, but you can tell that they don't actually fit as well as the original ones. There's a slight difference, but again, they work. I haven't really had any issues. Okay, this should be done. Okay, so we went through a lot of wick. Damn, I gotta account for that. But JBC standards are better in my opinion. Yeah, they might work better too. But yeah, from my experience, those non-original ones, they don't fit as well. They're a little bit off. I heard a lot of good things about them, but didn't try myself. I'm using Axiom C245 tips at work, and they are comparable in durability to JBC ones. As far as the durability, a lot of it depends on how you use it. You know, you can stretch the cheap ones, or you can kill the JBC original ones pretty quickly as well. So yeah, how you use it is kind of crucial in that aspect, and what you use it for, right? Because I think wicking is one of those procedures that use up a lot of the tip than you know, regular soldering. Nice one, thanks. You got it, Joey. It just got delivered an HP11 Gen with LCD color lines with LCD movement. Reflow pins of LCD if cable don't fix. I've had a monitor that stopped working, right? And you just see the lines going across and just kind of, you know, visual snow, right? I spent a lot of time, that was years ago. I spent a lot of time playing with it. And I even went as far as getting a replacement motherboard off eBay. I replaced the motherboard and it didn't solve the issue. And it's mainly because back then I don't know, I didn't have as much knowledge and experience as I do now. Now I would fix it very quickly. It was a faulty port. It was just a faulty port. Motherboard was good. The screen was good. Power supply was good. Everything was good. It was just a bent pin in the port. I should have looked at it and that should have been obvious. But back then, I failed on that one. So yeah, usually it's just a port. Look at it. Now it's an Ember CPU. See that beautiful color? Now let's clean it. Come on, focus. What did I do with my spray? Is my alcohol spray here?
Yeah.
Oh.
Did you see the hamburger I put down there?
That's bleach. Thank you. Well, it was hyped up. All right. Oh, use moonshine. Nah. I'm not gonna waste good moonshine on a Intel CPU. Come on. What is this? Did I overheat the die, as you said? Oh no, it's coming off. Yeah. Okay, it looked like actual damage, but no, it isn't. Well, the reason I went outside to look for the spray, because I usually use the spray to scare Arlo when he's barking. I don't actually spray him with it, but he knows he's gonna get sprayed. So he immediately knows, like, oh, oops, I'm doing something wrong. I should stop. Today was actually because during the PTA meeting he was barking like crazy, so that's why I grabbed the spray and got him under control. But then I had to go ship the packages and stuff, and I left, and then all meeting Arlo was barking. So my wife kept throwing the little pieces of bread at him like he's a duck. But I got a lot of great feedback from the teachers. My son is a role model. That's cool, because he's very polite, he always listens, he's very considerate, very helpful, and every teacher loves him. I was kind of skeptical at first about this school because a few times he came back like kind of terrorized, you know. And I understand discipline and everything, you know, but you don't have to traumatize my son, right? For the sake of discipline, you know. But no, I think they're doing a good job. And he's picking up on a lot of stuff that he should. Well, he's struggling with math, but I struggled with math when I was a kid, so I don't expect him to be a math genius. Then I don't know. Then I would become suspicious if my son was suddenly a math genius, and neither me or my wife are. I would be suspicious. But now he looks just like me, so there's no way I would ever be able to get out of it and say, no, that's not my son. No. You just look at me, you look at him, and you know immediately, yeah, it's my son. Okay, gents, we got it. It's nice and sticky, but I'm gonna put some more flux. I'm gonna put some on my finger because it's organic, and I used to do it with the Q-tip, but problem with Q-tip is that it leaves those little fibers, right? So I prefer to do it with my finger. Because it's got to be a tiny layer, because without that the solder is not going to flow to the chip, and it's just not going to solder on correctly, right? But if you put too much, it's going to start floating, and the solder is going to go everywhere. Perfect. Now come on. Did we get it? Did we get it? All right. Let's see, Joey. I was thinking of getting one of them stations from AliExpress. Good to know your positive experience. Well, you will have to make few mods on it. But even in stock version, you can find it useful. I've first started using it, you know, at a stock machine, and I had some success, not much, but some, and then, you know, then I started modding it, and after modding, it really works really well, and especially when you have Rework Pro. That's why I wrote it. That's why. You know, again, it's another tool, just like with my flags, right? Just like with the eBay tool that I'm gonna be releasing hopefully early next month. I was gonna release it this month, but it's going a little slowly because there's a little bit of feature creep. But the same thing, you know, I needed that software, so I made it for myself, and then I shared it with the community for $35 a pop. Chiseled C245 are the most universal in my opinion. Using them a lot. They have pretty big thermal capacity, yes sir, and you can use them, use the sharp end to do precise work too. Yes, yes, especially if you have a good one, because I'm using relatively cheap ones. So I can't really use the chisel for precise work, but yeah, if you have a good one, you can use it for very precise work. It's a very universal one. That's the one I use for wicking, because I don't have the one that is more appropriate for wicking. I use moonshine. All right, woodwork to clean. WPULD, work to clean lightly. Gotta know what that is, man. Normally a well-behaved child has a good upbringing. Normally. But thank you that you're giving me credit for that. I don't think I deserve any. I'm very far from being a perfect papa, but I definitely do my best. Quick question, how long on average does it take for the solder of a CPU socket to melt? I had a heat gun on mine for 30 minutes and no dice. Yeah, you're not gonna be able to do that with heat gun. Forget it, man. Forget it. Heat gun is not for CPUs. You can, you know, if you want to remove the CPU as we did this one, right? Especially without preheater, you can point your heat gun at highest airspeed, highest temperature, and just keep it for hours. It's not gonna let loose. It's not about the temperature, it's about the temperature distribution. You need for that, you need a BGA station, no way around it. It's just, you know, you're pushing a lot of temperature, but the CPU and the board are dissipating that temperature very quickly. So no way. Okay, this looks aligned, right? Now let's go grab some solder paste and some balls. Hello Raf, are all sockets in AliExpress, especially LGA 1700 from Foxconn? Hi NKK, no, they are either IC or Foxconn. The IC are usually, because it's not a rule, but usually Foxconn are lead free. They have lead free solder on them. The IC have leaded solder, low melt 185 solder, which means they drop quickly, they drop nicely, they don't require a lot of temperature, so it's easier. Foxconn, on the other hand, they are heavier. They are about 1 gram heavier than the IC, so they drop better, right? But you have to heat them up. You have to heat them up very nicely. So it's kind of, you know, pick your poison. There's no perfect solution here. Okay, this is my solder paste. Mechanic. The melting temperature is 158. You want to see my balls? Here are my balls. These are 0.3. Let's see if I have 0.45. 0.2. 0.5. And that's all the balls I have. I only have 3 kinds of balls, and none of them are 0.45. So that solves our problem. There's no way to use balls on these, because I don't have the proper size. So what we're gonna do instead is just use my trusted solder paste. It's way overdue, but on the other hand, that usually is better when it's a little bit drier. And now the whole difficulty of this is to just leave the same amount of paste in every single spot over here. But you can't use too much force, because if you force that solder inside, then it's gonna, because you can force it in, but it's gonna go underneath the stencil and, you know, create the bridge even before it gets hot. I've had a lot of experience with that. So it just kind of, you know, work it very slowly and don't force anything, and it should work. I still think it's easier than working with balls. I don't know, but I guess to each their own. Because sometimes I watch Tony doing the reballing. He uses balls, and he makes it look very easy, right? Basically, you know, he just drops the balls, and they all go in the right places right away. That's probably both the jig that he uses, the stencils and stuff like that. And recently I found out, maybe not super recently, but some time ago, that you can actually order a custom stencil for the chip. Because before I thought, you know, if I can't get a stencil for something, there's no way I can reball it, right? And then I found out that, yeah, there's a way. which is pretty cool. What's with this one? Yeah, I guess it's... What do we have? Yeah. As soon as I get my rework station, I will buy your license. Alright? It's only $35. Shipping worldwide. No subscription. One-time purchase. It's a steal. And I put it against any other software that uses PC410 controller, and they got nothing. And even if because some people like the PSoft and say that it controls bottom heater. I mean, you have to modify your machine if you want the bottom heater control, sure. And not every PC410 actually allows that. So the majority of those IR6500s, the controller that comes with it does not support second heater. There is second output, sure, but it doesn't work. There's a pinout for it, but no actual functionality. So yeah, so that's pretty much the only difference. Rework Pro does not control the bottom heater or the second output of the machine, because I don't have the proper machine to test it with, so for development. All right. But that's the only thing that you might hold against Rework Pro, and I don't think you even need it. I mean, once you have the machine with second output, then yeah, I understand you want to use it. I don't know if I moved it. Probably not, because the flux is now acting like a pretty good glue at this point. So I don't expect it to move, but we'll see. I may have messed it up already before even starting heating. But that's the whole point. We're doing a little test over here. Okay. Is this done? Finally. Okay, I think it looks good. So now it's gonna be interesting. What do we have? Let farmer deleted message. Haha, I think it's cooling to fail. Flags around plus paste. Well, you shall have your answer very soon. I'm gonna lift it a little higher and just a little. Like this, because I don't want the balls to start joining at the top, which is not the worst thing, but still I don't want that. I'm doing a BIOS for some Central America tech remote. All right. How's that going? Yeah, I still haven't listed our BIOS repair service. It's on my list. It's on my to-do list. I'll try to do it this weekend maybe, because I've been kind of busy with everything. But I have to list that. I want to list the CPU swaps. I want to list a what else I was gonna list? I was gonna list something else too. So I have few listings that I have to do. I'll get to it. Just I didn't notice that my cloning service was ended, right? And I was wondering, why do I not get any cloning jobs? And because my listing ended. And the same with PlayStation. I don't know how it works, but when the item sells, you hit relist, but it's a new listing. You don't get that history of that you already sold 10 of these. So that kind of sucks. All right, fellas, what temperature? What temperature? What airflow? You need to just increase the quantity on the listing to prevent it ending for that. Yeah, that's what I thought, because I think that's what I've been doing with ECM repairs, because I have I don't know, like 70, 80 sales on that one. I wouldn't like to lose that, because it looks a lot better when you have a listing that has, you know, 100 sales on it instead of 0. But it's I'm not satisfied with that, because I probably should have done it, but you know, I had one last left, because that was the PS5 HDMI port replacement, and the 10th sold like a couple days ago, and then I remembered that, oh, I was gonna increase the, because I increased the price, I increased the, you know, I upped the price, but forgot to actually increase the quantity, and that was a mistake, because I thought if I hit relist, it'll be the same listing, but it's a new listing, which means all of the links that you had to that listing, you know, they're all invalid. And right now, if any of those repairs that I always list in my video description, if any of those go away, then suddenly I would have to update, you know, 500 videos or 600 videos. I don't even know how many videos I have, but I would have to update the description on hundreds of videos. That would be crazy. All right, what do we have? Jimmy, 350 to 375 are 2. By 2 you mean on the scale from 1 to 8, like I have on this one? So like minimum. Gas Mark 5, 350 through R2 of max 10. Okay, so around 20%. Okay. Yeah, that's what I thought. I think last time I was doing it on... so my maximum is 120 liters per minute. So 10% of that is 12. I want to do 15. And you said 350 to 375. Isn't that going to be too high? The solder melts at 150... what was it? 150 some... 158, so call it 160. Right now I set it to 290. What do you think? 290 is gonna do, or should I do? Because also depends how far away you hold the nozzle, right? So if you have 350 but you hold it far away with low airspeed, it's gonna get the job done as well. I think it lifted here a little bit. Yeah, I'm not sure about this. It depends how you point the light. Yeah, it's maybe not perfect, but yeah, it should do. I'm gonna put the light maybe like this, and this one from over here. Yeah, it looks okay, provided that we're still aligned with the actual CPU, because I don't know if I didn't move it, but once my flux solidifies, it acts like a pretty good glue, so it shouldn't. Yeah, move constantly all around, no nozzle, yeah. You hold center down with tweezers. Well, again, it's not gonna prevent if you overheat it and that center pops, then even the tweezers or magnet or whatever is not gonna help. But right now it's sitting on the magnet, right? So it's constantly holding the stencil to the chip. But still, it's not gonna, you know, you're not gonna prevent it if you don't heat it properly. You're not gonna prevent it from flexing. Joey, it's 3 a.m. here. Oh, I'm off to sleep. Take care, folks. Have a good one. And thanks again, Raf, for the great video. Thank you, Joey. Always appreciate it. Always nice to have you here. Sorry I kept you this late. But yeah, it's past 9 o'clock over here. So it's pretty late over here as well. Well, good night, man. Don't stay up too late. What's oh, tomorrow is what, Friday? No, Thursday or Friday? What's today? No, today's Thursday. Yeah, because they were mowing the lawn. Yeah, so tomorrow's Friday. Hopefully you don't work on Fridays. You're on the balcony, babe.
I was.
Oh. Ventilate. All right, I'm gonna do 290. I'm gonna start with 290. If the balls don't want to melt, I'm gonna up the temperature. But it's gonna take a few minutes to actually melt it. In either case, what I found is the patience is the most important in this procedure. You have to really do it slowly. Otherwise, it's not gonna work. There's no cheating with this one. All right, let's get to it. Let's move the flux away, because we'll see once my flux is going to start melting, the stencil might start moving. That's why we have the magnet. So I'll try not to move it, and we'll see. All right. Oh yeah, this is nice. I can move it across my hand and it's not burning. So I'm gonna start with that. I'm actually gonna grab a thermometer, and we're gonna try to check the temperature on it. It's at 36 degrees right now. And let's start moving it around, slowly heating. We'll see if the magnet does its job. you need rapid melt to catch the melted solder to the pod. So with I have the reason I was never, or I had so much issues getting this done, was because that's what I was trying to do, to just heat it up too quickly, too rapidly, and then the stencil just, you know, deforms. So that's at least my experience so far, but we'll see. I'm gonna do it slowly, very slowly, and that's usually what gets the job done. And we're gonna be monitoring the temperature. We are at 80 degrees. There is some action there already. I think that's not looking good. See those little holes that are being made? It's not supposed to be doing that. So either it's not sitting flush, or I don't know. But I'm just gonna keep doing it until we melt the solder. No way around that. We're at oh, it's hard to say. Around 80 still. Because if I put too much solder, too much flux on the CPU, then it's also not gonna work, because the flux is gonna start bubbling, and it's gonna, you know, push the solder out, or it's gonna create bridges underneath. But it's already not looking that great. Use the preheater. Yeah, my preheater is not big enough for this, and yeah, the other thing is that if I put it on the preheater, the CPU is not sitting flush. It's kind of there's a little bulge on it, so it either moves to the left or right. It's just kind of wobbly, so that's why no preheater. But yeah, with preheater, especially the memory chips I've done, the best results I've had was on the preheater, because then you just turn on the preheater and you wait, and it heats the chip first and stencil last, right? And right now the stencil is preventing the chip from heating up, right? So not ideal. We are at around 90 degrees. Yeah, because now through the stencil we need to heat up the chip. That's why it's gonna take so long, because if you heat it up rapidly, then the stencil is gonna heat up, not the chip. So the solder is gonna be flowing on the stencil, not on the chip. It's not gonna catch the chip. And with memory chips, especially the SSDs, they are multi-layer chips. So if you put it on the preheater, it's a sandwich, right? You put it on the preheater, if you remove the stencil too quickly, then you separate the chip. So in either case, this is rather difficult procedure in my view. We're at 100 degrees. It's gonna flex. Well, it's gonna flex if I heat it up too quickly, or if I heat it up. Oh, it's catching the magnet is catching my nozzle. I forgot about that. That's one of the pains over here. If you put the nozzle too close to the to the stencil, then the magnet is holding it. The magnet starts pulling it. But yeah, it's gonna flex if I just put the nozzle close to it and just start heating up the center. Then it's gonna start flexing. Move all around circle to spread heat evenly. Yes, sir. That's what I'm trying to do. But the flux underneath might start bubbling, and it's not gonna work very well. Northwest Repair Reballing a GPU is a good guide. Yes, I've seen that. Yeah, I've seen it. But that's why I know he uses bowls, right? But in this case, even if I wanted to use bowls today, I don't have the proper size. I have 0.4 and 0.5, and this needs 0.45. So I will have to get the proper bowls. Because I don't have bowls, guys. No bowls. Okay, it doesn't want to go higher than 100 so far. So we're gonna have to up the temperature in a second here. I see some flux oozing from underneath, which is not ideal, but I know. And I see some of the solder is getting ready to melt. I see it already. So maybe this will be enough. See some of that solder on the left. It's already getting ready to be melted. But the important thing is that we need to heat up the CPU, not only the stencil. That's why it's got to take a little while. Yeah, I remember the first successful reballing I had. I was so happy, but it was only because I took so long to preheat it that I was not expecting. And then as soon as I had first success, I figured, yeah, I can speed it up. I've done it before. So yeah, let's just point and shoot, right? But no. This is one thing that requires more patience than precision. Yeah, we're barely at 130, going to 130, but barely above 100. But it's growing, the temperature. Oh, swing long way, not short way. Okay. That makes sense. It's just easier for me to swing it this way, like this. And I don't know, I guess I'll just switch hands. And the worst part is that the magnet is catching my nozzle. So you have to be careful about that. If I can get it on this settings, if I can get it to 150, we're golden. Because then I'm gonna just close put the nozzle closer, and and the balls are gonna start melting. But it needs to be preheated very nicely. What do we have? A little over 100 degrees. Jumping to like 130. So I think I will have to up the temperature because we're doing to 90. You guys suggested over 300. So we'll see, but let's heat it up slowly first. Now do circle only. It's better long, so it keeps most of chip heated. Okay, let's do circles now. It keeps catching me. So it's really difficult, but I may need to up the temperature because it's not heating up. $310. Well, the stencil is not flexing, so that's a good sign. And we're getting close to the temperature of melting. As long as the CPU heats up properly. This looks a lot better when you watch other people do it, and it's a sped up footage. They just boop 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 boop. Alright, move the nozzle around and the balls are forming. Sure. It looks different in real life. But I see some signs of shininess. So we're getting close to melting. Yeah, 120, 130. 150 even. So yeah, we're getting there. It's almost there. I may need to up the temperature again. Right, flux purge means it's almost time to go up temp to melt. Okay, so 330. Doesn't want to go much higher than 140, so we're just like 10 degrees off. Okay, up the temp and long circle only, no waves. Okay. Uh, 330, so let's do 340. This magnet is pretty strong. 370. Okay. Well, think I won't be able to do it on 330. Or okay. See what happens. Okay, I got distracted and it caught my nozzle. Okay, 360. This would be so much easier on IR station because I could just do the profile, you know. But now I don't know, because it may have moved now that it caught my nozzle. Yeah, some of those are ready to be melted. We're almost there. Yeah, we got 160, 170, 150, 130, 120, 130, 160. So we are almost there at 360. Oh, you strong magnet, yes it is. Okay, we're going up to 380. If this doesn't do it, nothing will. Just as long as we don't catch the magnet. Yeah, we got some balls forming. There you go. Yeah. Now we get there. There you go. No. Nozzle too thin? I'm not using nozzle. I can't go any wider than this. Okay, do you think this is done? I think all the balls are melted now. Not to say this is successful reballing, but at least all the balls are melted, I think. Now should I put some flax on top of it to aid with it? What do you think? Yeah, I think this is done. Good, let it cool. Okay, let it cool. I think like over here, right, and here this is gonna catch the, and there's something not right over there. It might be difficult to remove the stencil off of it. But the stencil didn't bend, all the balls have melted. So if this doesn't work, that means I just have to improve the I just need to improve the applying the solder paste. Plus this solder paste is a little old. Lead farmer now needs more slow, closer heat on some areas. Yeah, melt versus melt and stick to pots. Yes, yes. We'll see. We'll see. Let it cool down. Let me get a little beer because I ran out of beer. Yeah, it doesn't look that great. That's why I was thinking maybe if I put some solder on top of it and heat it again, right? Use knife to scratch the under stencil exit balls. You mean after I remove the stencil? Yeah. What I do, if I do mess up, you know, reballing, and the stencil has some solder melted into the balls, I just put the hotter, a maximum airflow and high temperature, and I just blow through it, and it usually just, you know, cleans the stencil by itself. Okay, a little flux and reheat, but up 10 degrees if this fails. Well, what do you think? Shall we cool it down and test, or shall we reheat it and put some flux on it? Because it could be that the CPU didn't heat up properly. Because some of these balls look perfectly fine, but some not so much. So dark shadows means it dropped to pod. Send tell bottom right. Yeah, unless we use different lighting. What do you think? Yeah, the bottom right doesn't look that great. Bottom left doesn't look that great either. And especially over here, it doesn't look good at all. It looks like the balls are in the stencil, stuck in the stencil. Yeah. flux and reflow. Try separated, but I suspect it's gonna have some not stick. Yeah, and yeah, looks good. It was light. Might need 10 degrees more and reheat. Okay, 390. That's 10 degrees more. What's the temperature on it now? It dropped to like 75 degrees, 77, 79, 80, depending where I look at it. Okay, well, what's the worst that can happen? This doesn't look that great anyway, so let's just try it. And like 3 times my nozzle got caught by the magnet, so you know, that also could be the reason it's not looking that great. Especially the bottom over here. I'm gonna try to focus on the bottom over here. And where's my flux? We'll see. Well, it can't get any worse than this anyway, so we'll see. Uh, 4 out of 10 airflow. So I'm gonna do 25 airflow. And we'll see. What's the temperature? 160, 170. I might try next time with the preheater or the bottom heater, and not do this. But I've succeeded with this before, so I know I can do it. It's just, you know, I don't have much experience with this yet. But I'll get it. It took me a while to get the socket replacements, but finally I got it. And I'm happy with the results I get nowadays with the socket replacements or CPU swaps and stuff like that, but provided that I have Reballing CPU. That's usually what I tell when or at least until now, when someone needs a CPU swap or something like that. I say as long as you provide Reballing CPU, it's good. I can do it. But if you want me to Reballing the CPU, that's not something that I can provide at the moment. But maybe now I will. And the stencil is going to be so dirty, I'm going to have to run it through the ultrasonic cleaner. Oh yeah, now it's starting to look a lot better, actually. Right? Doesn't it look better? Yeah, I'll try bowls. I'll try with the bowls. But I have to get them first. I think we're good on this side over here. I'm just not liking these over here. It's like the stencil is hotter than the chip, and the solder is flowing to the stencil instead of the chip. Yeah. This whole bottom side over here, I don't like this, and I'm not sure. I'm probably putting too much flux on it now. It's all gonna burn, but what are you gonna do? Or I put too much paste in some of those, and that's the issue. It could be. Yeah, these over here. Something's not right here. Oh, and looks like the stencil, not stencil, this jig, look at that. We bulged up over here. I probably should put some Captain tape or something on it. Well, I don't think this is gonna work perfectly, but I think we're gonna have the majority of the balls soldered on. Definitely not all of them. Yeah. Well, we'll see in a second now. Because maybe that was just a flux and I thought it was solder bubbling out and it was just a flux. I don't know. So yeah, it was when the tip got stuck with magnet that got different look. Should still be close enough. Yeah, that's what we're hoping. That flux may not be the best for this because it bubbles when the IPA evaporates. Yeah, either IPA or glycerin. Well, bubbling is from IPA. Smoke is from glycerin. I don't know. Oh, you say it looks really good? Okay. If you say so. We'll see this damage over here. This big bubble. Because it's not exactly... Yeah. So now... Yeah. I'm not sure what to do with this. Because it needs to be flat. Now it's not going to be flat, so... That's going to make it more difficult. Too bad, because it was a pretty expensive jig. What's the temperature on it? 98 degrees. Cooling down slowly. cut that material out. Yeah, that's probably what I'm gonna have to do. Because this is not gonna work now with the memory chips if it's bulged like this. Yeah, this little ball, what is this? Is that oh yeah, that is solder. Oh. Yeah. So either there was maybe too much solder in there, or these two balls, yeah, probably combined. Because I probably won't be able to separate these. Which is kind of too bad. Yeah. Yeah, this will not want to separate, and there's the same here. Yeah, that's why I was kept putting more flux over here, but I guess I didn't put enough, or something else. But some of them look good. And here's another one. Yeah, this will not separate. I'm gonna try to separate it now while it's still hot. Touch with the soldering iron. Let's see. Yeah, that works. That actually works. All right, now I should be able to separate it. Still a little too hot, but I don't know, maybe this one too. Let's see, can we separate it? It's holding very well, but it's because it's holding with the flux. So let's give it a little drink. And that should do it. We're gonna have to clean the stencil anyway. And I don't want to bend the stencil by prying it too much. Oh, knife them. Wig the Wick and solder, yeah, wick the solder, yeah. Okay. Knife them, IPA spray it, IPA spray and brush it. I think you waited too long. Flux glued, yes. Heat and clean IPA with brush. Okay. ZBrush. I have a pretty good brush here somewhere. No. Oh, there's one over here. I see the ball that is gonna hold. This one over here. This is gonna hold. And yeah, clean the tip. Okay. Yeah. Now, I already see that there are issues, but it's not as bad as I expected it to be. As you know, in some cases, you know, if just a couple balls are not right, you can replace a single ball. So it is a possibility as well. Oh, well, go to my channel. No. Okay, I see already suggestions. Look at our stencil. Now it's battle tested. Yeah. Well, as long as it's not damaged, we can keep trying, right? Okay, so I say this is not too bad for a first try. It doesn't want to catch focus. Come on. Yeah, I need to do manual. There. Okay. What do we have here? Well, we have definitely one that didn't solder on, this bowl over here. The pot is empty. Some didn't soak enough. This could be related to my nozzle being caught. The shape of the bowls, not the best. This one is super big. So that was probably the problem of applying solder paste. These are a little bit too big as well. So that was the problem of applying solder paste. This problem would not exist if I used solder balls. But for a paste, it's not that bad, right? I mean, it won't work or wouldn't work, but you know. There's this one's a little smaller, I think. Yeah, all over, yeah, all of them over here. They just, see, I just didn't put enough solder paste over here, and that's what it was. I did put like some of these, like this area over here, it looks perfect. So some of the areas are really good. So it was just the problem of applying solder paste. That nozzle catching my magnet probably didn't help either. Oh, and there's one more missing here. I don't know how that happened. Oh, it probably came with the stencil. There's probably some solder in the stencil left over. No, we don't have any solder left in the stencil. So probably it didn't solder on and it was just left in the stencil. And I just removed it when I pulled the stencil. I probably removed it. So this is very close for a what do you guys think? For a first try, I'd say a 94% success. Lead Farmer, thank you so much. I would say even 95, maybe. Rub gently on a piece of paper and then reflow. This will even the balls by sending the bigger balls down a bit. Oh, interesting. Wig butt areas and add balls. Yeah, that's something that we could do. It's not something that I like doing, but yeah, I could do it. And yeah, probably if this was, you know, done better and this was a working CPU, I would probably just put a flux on it and reflow it afterwards. Probably. But there's like too many. Look how many over here are too small, right? But that's purely because I didn't put enough solder paste, and some of them have too much paste. Okay, stencil did not deform. Stencil is fine. Yep. So no damage to the stencil. No. So that's good. We can try again. I'm actually gonna drown it in alcohol now to get all that flux off. This is not bad for the first try on this CPU, and especially with solder paste. But I think we're gonna go with the balls, because there's no way to tell once you put the solder paste, right, and you soak all the holes. There's no way to tell visually whether some holes require more paste, right? So that's why I kept rubbing it, just, you know, going by feel where there could be more, more paste that is required. But I definitely missed this spot over here, and that's why, because this was sitting this way. Remember? This is the area where it just kind of looked off, right? There was not enough solder over there. That's why it looked off. At that point, perhaps I could have stopped the procedure and put more paste in. That probably is what I should have done. So it is some kind of solution. But it's horribly time consuming in general. That's the main that's the main issue with this. I think with solder balls it would be a lot less it would be much less time consuming with solder balls. Okay, the stencil is nice and clean. Now, if I put it back, can I put it back? Let's see, let's catch a corner here. No, it doesn't. Why can I not put it back over here? Am I doing it? Oh, that's why, because I'm on the wrong side. There you go. That's better. That's better. There. Now it fits. Okay, so I can put it back, right? And now we see which balls are smaller. All right, so this side over here. Hang on, because you can't see. This side over here, everything looks good, right? This side over here, the bottom, yeah, we see missing ball over here and smaller balls over there, right? And some too big actually. Same here, right? So technically, you know, right now, yeah, why is this ball so big? Over there, yeah. Some are way too big. So technically, I could... Yeah, this one's way too big over here. Yeah. That's, it probably stole some solder from the neighbors over here. But technically, I could, because since the majority of them are good, so I could just put more paste over here, right, and reheat it again. This could also work. Well, I'm kind of happy with this for the first try. It's not that bad. At least now I know what to expect. And I don't know. I might try this particular CPU again. Just so I can, so before I even attempt the actual CPU, I'll make a goal for myself to get this one resoldered or reballed perfectly. And once I get this one perfect, I'll do the other one. Yeah, weak buds, yeah, other. When you spread paste while on a hot plate, it bubbles some and flows to fill. Yeah, that might also have been the problem. Spread, head slightly and repaste, yeah, or heat slightly and repaste. You have to clear big bowls area, then repaste, yeah. Solder pen and touch solder, and you added solder wicket, then add paste with stencil, yeah. About the paste, repair the paste is the key. Mix with flux and make message. Do not put flux on CPU. Well, so the reason I put flux on the chip is twofold. Number one, if I don't put flux on the chip, from my experience at least, it will not, the solder will not flow to the chip. It will just not adhere to the chip. It'll stay in the stencil. That's been my my experience so far. But the second, and even more important, when you work with the paste, the stencil needs to sit on the chip firmly, very firmly. And when I put tiny layer, because I put really tiny layer of flux on it, then I stick it on, and then I know that it's not gonna move, right? And then I can freely put the paste on, right? So that's why I do it with the with flux. So I have tried it before without flux, and it never worked. It just, it stayed in the stencil, even if the chip is super hot. And even if you heat from the bottom, it just doesn't want to flow. It doesn't want to bind with the chip. It just binds with the stencil, and then it's pain in the ass to remove that solder from those tiny holes. Flux on CPU is almost not needed. Yeah, I agree with almost. He means add a little flux and paste, mix separate from. Oh, you mean add more flux to the paste? I don't know. I could try that. Yeah, bowls are easier. I think I'm gonna go with bowls. I think I'm gonna get 0.45 bowls, and the next try is gonna be with bowls. Cause yeah, it does look like repasting is really challenging, especially since you can't really. Oh, you mean massage the paste with flux? Okay, right. So once I put the paste on it, then just massage it on the top with flux. Yeah, that might also work. But yeah, I think I'm gonna go with bowls because the main issue is the feedback. You don't get feedback. 0.4. Well, I do have 0.4s, but this stencil says that it should be 0.45. So I'm not sure. funny that I have so many. Well, I only have like 3 or 4 sizes, but I don't have 45, which kind of sucks. But yeah, it's good. We're gonna have to do the balls, because it also needs to be reliable. Now consider how much time it took, right? And that lack of feedback when you put the paste. You don't know if every hole has the same amount of paste until you start heating it up. And it's super time consuming. With balls, yeah, I would just put it on and if the ball is there, then it's good. Oh my goodness, what happened here? Yeah. I guess we didn't need this much, that high of a temperature. Yeah, I'm gonna have to cut around here, because now I don't do a lot of these SSDs. I don't know why I even got all that stuff. Well, I guess I got it because I wanted to finally get some success. But then I figured it's not the problem of the jig. It was the problem of me heating it too high, too quickly. That's why the stencil wouldn't work, right? It would flex, but that wasn't the problem of the jig. However, with these magnets, I mean, it's awesome that the stencil stays in place, but it's a real royal pain when your nozzle gets caught like this, and it's really because it's 2 big neodymium magnets, right? It has a lot of sticking power. Okay, that should do. Oh, see, it's grabbing my tool. Okay, because as long as it's flat, it should be fine. You would think this would withstand proper temperature, right? But I guess not. And also, this expects that you heat up over here by the magnets, and there's a big stencil around. So maybe that's why. Not good. Not good. I think we're ruined here. This is not flat anymore. Alright, actually, maybe. I'm not sure. But the chip is sitting over here, right? It's not sitting on this, it's sitting here, and this goes flush on the chip. So maybe, yeah, this isn't ruined. Yeah, so I can still use it for SSDs. Not that I need to for reason, but you know, from time to time maybe I'll get some SSDs to resolder. Oh my god, my neck is killing me now. This took a lot longer than I thought it would. But, well, I'm happy with the result. I know it looks crappy and maybe my bar is really low, but I'm happy with the result because I got my answer and at least the majority of balls are actually reballed properly, so it's better than I thought. Plus I got a hang of wicking it, so I know how much temperature I need, that I do need to use the leaded solder to actually get it done. And that trick with the Q-tip, it's actually very useful as well. I'll keep that. And I lost a whole bunch of wick on this. I have to remember to just kind of maybe do it differently next time, so I can save some wick. Because if you put the big blob of solder and solder it on first, and then pick that blob and remove it, you use a lot less wick. Use aluminum foil. For what? Oh, you mean on the jig? Put aluminum foil. Right. Yeah, that's a good idea. I'll do that next time. That way, yeah, because aluminum foil is gonna protect from that heat. Balls. Remove stencil and heat. Yeah. So you. Flax, stencil, put the balls on, remove the stencil, and then reflow. I'll try that, but I think first I'm gonna try with my regular method. So stencil, balls, reflow, then remove the stencil. Because from my experience, when I do the manual reballing, when I just put manually balls and then heat it, oftentimes, you know, that airflow is gonna push the ball a little bit, especially when you have some flux on the board, and they start touching and they start bridging, and it's more frustrating than it's worth. When it's in the stencil, when the stencil is on, the balls are kept in place, right? Clean solder tip if releasing a stuck ball. Yeah. I should have done that. So 0.4 balls on 0.45 stencil. I'll try that. Stencil has to be clean of flux. So balls don't stick. Yes. This was new stencil. Hasn't been used before, and now I cleaned it. I think it's not sticky, so I think I got all the flux off of it, so it's ready for the next try. Yeah. Lowest error 2 and 370 with no stencil. Yeah, I'll try that. I'll try that as well. But in all fairness, if I can get it, if I can remove the stencil without it disturbing the balls, then I can just put it on the bottom heater, right? Like this, and just turn it on, and it'll melt nicely. I mean, it doesn't sit flush, right? It's wobbly, but it should do. It should get the job done. Now the reason I didn't do it with this, because once I have the stencil on, it's just too big, right? But with this, it fits perfectly. So that would be easier for me to heat it like this. And I can subsidize with the hotter gun as well. All right. Oh my god. Oh, it's 10:30. Okay, we did a pretty long stream. How long was this stream? 3 hours and 17 minutes. Damn. That was a long one. And looks like we peaked at... It doesn't say what was the peak. I guess around 15 users. Yeah, around 15 viewers. That was our peak. Not bad. All right, I gotta get some rest, guys. Hope you have a lovely night. Add hot air temp with that plate, easy. Yeah. Oh, Steven, evening. He caught us like at the very end of the stream. Some went off sleep. UK, yeah. UK definitely went to bed because it's what, like 4 a.m., 5 a.m. over there. So yeah. Steven, my life is done. What's the, in a good way or in a bad way? You're set for life, maybe? I was streaming a teardown of programmers. Oh, that's why. Okay. Okay. Yeah, because I read my life instead of my live. The V. Yeah. Oh, so you streamed late as well, huh? Well. Yeah, we did some reballing. Some reballing action. With estimated by the community 94% success. I'll take it. 94% success, I'll take it. I'm happy with it. And I have to clean up all this now, but I'm not gonna do it today. I'm gonna leave it until tomorrow. Oh, it's 7, okay. What? Is there like 3 hours difference between us? Damn. Right. Yeah, because we are East Coast guys over here, so it's late for us. I guess, yeah. Well, it was, yeah, human hours. Jimmy, thank you so much for joining. Good night, man. Thanks for all your feedback. That was very helpful. And of course, Lead Farmer, thank you so much. And a few other people that also gave me a lot of Surge 101. Thank you so much. Who else did we have here tonight? Joey went to bed already, but if you're watching the next day, the ending of the stream, thank you so much, man. Much appreciated. NKK, thank you so much for joining. Bubble Jack, thank you so much, man. Who else did we have here? Dreamspec, thanks for dropping by. Thank you so much, man. Stu, thank you so much for dropping by. And R413, thank you, unless I have mentioned you before. Thank you guys very much. Always nice to see you guys. And of course, Steven, thank you for dropping by. Oh, I am left coast behind enemy lines. I don't know, man. We're like Florida, Georgia. That's where the action is going on. You know, California, Florida, Georgia, Pennsylvania, of course. Ohio. No, was it Ohio? No, Chicago. Yeah. Well, thank you guys again, and I shall see you guys, I guess, probably tomorrow. I got 2 videos already queued up, so tomorrow morning and the day after in the morning there are videos going up. But I might do some live. Tomorrow as well. Good night, Lead Farmer. Good night, everybody, and thank you so much for joining us.